Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magdipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
Hello guys, this is Justin Bibilan, aka Uganizon118, and welcome to my YouTube channel. So last week, or last in my episodes of learning organic chemistry, we discussed about line band structure and electron dot structure, or the Kikuli structure and the Lewis structures for organic compounds. Now let's move on to the families of organic compounds. So here we are going to start the organic chemistry part of our topic or our lesson. Okay, so here we go. So we have general classification for organic compounds. Number one is hydrocarbons. Hydrocarbons, these are molecules that contain only hydrogen and carbon. So from the word itself is derived hydro, which means coming from the hydrogen, and you have carbon, which is a carbon. Okay, so these are compounds that contains carbon and hydrogen only. And we have also substituted hydrocarbons. That means that one or more hydrogen atoms is actually replaced by another atom or group of atoms. So I have here an example of we can distinguish a hydrocarbons from substituted hydrocarbons. So this is an example of a hydrocarbons. So this is a hydrocarbons. Okay, this is a hydrocarbons because it is actually contains carbon and hydrogen only. And all of them are also hydrocarbons. Okay, this is also a hydrocarbon because it contains carbon and hydrogen, and so this one is also a hydrocarbon. When you look at these three molecules or these three compounds, they're actually different. Why? It's because the second compound, this one, is actually the hydrogen here is replaced with your CH3. Okay? So this compound is what we call a substituted hydrocarbon. Because how do we define substituted hydrocarbon? If one or more atoms is actually replaced, or one or more hydrogen is replaced by another atom or group of atoms. So your hydrogen is replaced with another atom or group of atoms. So in this case, it's a group of atoms, which is actually a CH3 atoms. Okay, so your hydrogen is replaced with your CH3. So the third compound is actually also called the substituted hydrocarbons because both of these hydrogen, so you we actually define it as one or more hydrogens. Okay, so we can actually replace two or one or more hydrogens with a group of atoms. So in this case, this hydrogen is being replaced by this group of atoms, and the other hydrogen is also being replaced by another group of atoms, which is this one is also a substituted hydrocarbons. Okay, but basically all of these molecules are hydrocarbons. Okay, because they contain only carbon and hydrogen. Hydrocarbons can be further subdivided into aliphatic hydrocarbons, which are alkanes, alkenes, and alkynes. Okay, these are called aliphatic hydrocarbons. We have alkanes, alkenes, and alkynes. So we will know further what are all of these aliphatic hydrocarbons. Okay, alkanes are saturated hydrocarbons, which means that they only contain carbon to carbon single bond. So when we say saturated, okay, it only contains carbon to carbon single bonds. Okay, so Please be aware of that. For saturated, that is actually alkanes, carbon to carbon, single bond. For alkenes and alkynes, they're actually unsaturated. It's because they contain carbon to carbon, double bonds, and triple bonds. Okay? For alkenes, it contains carbon to carbon, double bonds, while for alkynes, it contains carbon to carbon, triple bond. So alkanes are carbon to carbon, double bond, while alkynes are carbon to carbon, triple bond. So these are example of organic compounds that belongs to the alkanes, to the aliphatic hydrocarbons, which are alkanes, alkenes, and alkynes. Okay? So the first compound is an alkane. Why? Because it only contains carbon to carbon single bond. So you notice it is carbon to carbon single bond. We have also another carbon to carbon single bond. Okay, so this bond here and that bond there are all single bond. So if it contains single bond, carbon to carbon single bond, then it belongs to an aliphatic hydrocarbon called alkanes. The second compound, as you notice, that it actually contains a carbon to carbon double bond. So if it contains a carbon to carbon double bond, then this compound is what we call an alkene. Okay? So alkene. If it contains a carbon to carbon double bond. Okay? So the last compound, as you can see, it contains a carbon to carbon triple bond. Then therefore, this compound belongs to an aliphatic hydrocarbon, which is what we call an alkyne. Okay? Alkyne. Alkyne. So this one here is alkane. So these are the definition for alkane, alkene, and alkyne. Okay? So they only differ on the structure of the compound. If it contains a carbon to carbon single bond only, then it is an alkane. If a hydrocarbon contains a carbon to carbon double bond, then it is an alkene. If a hydrocarbon compound contains a carbon to carbon triple bond, then it is an alkyne molecule or an alkyne compound. However, some hydrocarbons are actually cyclic. Okay? Remember that carbons can double bond itself to form a ring. And these rings are what we call a cyclic compounds. We have a cycloalkanes. These are carbons that are bonded to one another to produce a ring. Okay, so I have an example here, but before that, there are actually two kinds of cyclic. We have a cycloalkanes and aromatic compounds. Aromatic compounds, these are compounds that contain a benzene ring or derivative of a benzene ring. So we will know what is the structure or the formula for a benzene ring. So we will know the difference between cycloalkanes and the aromatic. So notice aromatic if it contains a benzene ring or a derivative of a benzene ring. For cycloalkanes, these are actually only carbons that are bonded to one another or to produce a ring. Okay? So the first compound is what we call a cycloalkane. Okay, so this one is a cycloalkane. So your carbon is actually bonded to one another and it can also double back to itself to produce a ring. So this is a cycloalkane. This is actually called a cyclohexane. Okay? So we will know later how to name this compound. The other one is what we call the benzene ring. Okay? So this is a benzene compound. So you notice that it has a carbon-to-carbon double bond, and these are actually alternating double, single, double, single, double, single. Alternating double, single, carbon-to-carbon bonds is what we call a benzene compound. Okay? So you notice its structure. However, we can also write the structure of benzene by this one. So some book will have this structure of a benzene because it actually your double bond here is actually moving. So we can move this, we can move that double bond there also, and we can also move that there. So that's why some book would have, they will just put a circle on the at the center of a cyclic compound, representing that it's actually a benzene compound. Okay, so let's take a look at our summary for the families for hydrocarbons. So hydrocarbons, we have two types of hydrocarbons. We have aliphatic and aromatic. So for aliphatic, our examples are alkenes and alkynes. For aromatic, these are substances that contains a benzene ring. Remember that it will only be an aromatic if it contains a benzene ring or it is a derivative of a benzene. Okay? For aliphatic hydrocarbons, alkanes which only contains carbon to carbon single bonds. For alkenes, only contains at least one carbon to carbon double bonds, and for alkynes, one triple bonds. Okay, let's move to functional group. So what is a functional group? A functional group is an atom or group of atoms arranged in a particular way that is primarily responsible for the chemical and physical properties in which it is found. Okay, so I have here an example of a table that comprises with a functional group and what family or of organic compound is this functional group belongs. So we have already found out those functional group earlier about alkanes, alkenes, and alkynes. And there are a lot of functional groups that actually belongs to some organic compounds. So, for example, if it contains a carbon-to-carbon double bond, then it is actually belongs to an alkene family. Alkene family, I mean. Okay? So, if it is comprises with carbon-to-carbon triple bond, then it is an alkyne family of organic compounds. If it contains a benzene ring, so this is what I meant by a circle in the middle, okay? And we can also write it as an alternating double, single, double, single, double, single. Then it is an aromatic if it contains a benzene ring. Okay, so if a compound contains a functional group of a benzene ring, then it is an aromatic compound. If it contains a halogen, like fluorine, chlorine, bromine, and iodine, then it is an alkyl halide. If it contains an OH, then it has an hydroxyl group. So this is what we call an hydroxyl group. Then it is an alcohol. However, if an oxygen, instead of H here, you notice that your hydroxyl is H here, diba? Okay, if it is replaced by an R group, R means it is an alkyl or an aryl. Okay, when we say alkyl, these are actually aliphatic. These are actually aliphatic substituents. When we say alkyl, okay, so alkyl from the root word itself coming from alkane. Okay, so alkyl are aliphatic substituents, or it could be it contains a carbon and hydrogen, okay, atoms, or it could be an aryl group. So aryl is coming from the root word aromatic. So an R there could be an alkyl or it could be an aryl. Okay. So if this R is replaced by an alkyl, for example, like CH3, we have CH3. Okay, that is actually an alkyl if it is CH3. And if R there is replaced by a benzene, then it is an aryl R. Okay, so in that case, if oxygen is bonded to this portion here and with the R there, then it is an alkoxy group, then the family there is what we call an ether. Okay, that is an ether organic compound. Okay, next is a carbonyl group. So a carbonyl group contains a carbon double bonded with your oxygen. You notice it's a carbon double bonded with your oxygen. This one here is single bonded with your oxygen. Okay, so carbon double bonded with your oxygen, then therefore it is a carbonyl group. So in this case, your carbonyl can be an aldehyde or ketone. So what is the difference between an aldehyde or a ketone? Okay, if if you have a carbonyl group, if you have an R there, you notice that if it is an R, then it could be an alkyl or a aryl. So if the other side is an H, then automatically it is an aldehyde. Okay? So if the remaining side is the bonded atom there is H, then this portion here is a functional group for your aldehyde, while your R is for alkyl or aryl. So it could be a CH3 or CH2, CH3, and so forth. So we will just discuss an alkyl compounds later on. And if it is replaced by an aryl or a benzene or a derivative of a benzene, it could be. Although this portion here, the C double bond OH, is what we call the functional group for aldehyde. Okay, it is a ketone if it is not an H. Okay, if it is another R derivatives or another R portion or an alkyl or an aryl that is present. So both of them could be an alkyl or the same alkyl, or the other one should an alkyl, or this one is an aryl, or this one is an aryl, or this one is an alkyl. If those two are meant to be R substituents, then the functional group there is what we call a ketone. Okay, so this one is a ketone. So an aldehyde, if it is an H, C double bond OH, it is a ketone if it is an R, C double bond O, R. Okay, so that is the difference between an aldehyde and a ketone. So more of that when we go to the topic about aldehydes and ketones. Okay. So if it contains a C double bond O, then your carbon is bonded with your OH, then it is a carboxyl group. So this part here is what we call a carboxyl group. There's one. That is a carboxyl group, C double bond OOH. Then the family there is a carboxylic acid. Okay? So if it is a carbonyl with with your carbon is bonded with a Cl, or it is an OR and others, then it contains an acyl group, then it is a derivative of a carboxylic acid. So it could be an ester or an acyl. Acyl, I forgot the name, but it belongs to a carboxylic acid derivatives. Could be an ester. If it contains a nitrogen, okay, if it contains a nitrogen, then it belongs to an amino group, and the family there is amine. Okay, so more of this when we go along to this topic about carboxylic acids, about aldehydes and amines. Okay, I have here a example problem. So for example, identify and encircle all the functional groups in the following structure. So from what we have done earlier, so we have here a functional groups there, and what is the family? So encircle the functional group, then the family it belongs. Okay. So we have here, automatically you can say that this portion here is. So by the way, you can pause this video if you want to answer it. So you can pause this video first. Okay. So I give you time to answer also. So this portion here, automatically this belongs to what? Family of organic compound. This is a a benzene. That's correct. That is a benzene. So that is a benzene. This one, that is a benzene ring. Alternating double, single, double, single, and double, and another single. Okay? This one is what functional group? See, double bond O1, your carbon is actually bonded with your OH. So going back to our this one here, the family, where is it belong? It's actually here. You notice it's C double bond OOH, then it is a carboxylic acid. So this one here is a carboxylic acid. Very good. That is a carboxylic acid, Ca. So carboxylic acid. How about OH? Automatically, that is OH. That is an alcohol group. Okay. So your OH here is an alcohol group. So this is an alcohol. Okay. That is an alcohol. Then we're done with this structure. So you can identify directly, and you can you encircle first the functional group, then identify if what functional group is this belong. So your COOH is a carboxylic. We have a benzene ring, then it is an benzene. So therefore the family is aromatic. Aromatic is the family of organic compound. Okay, that is a benzene ring, and therefore that is aromatic. Okay, and you have OH, then that is an alcohol. Then we're done.